So let's talk about lie detectors, why they're so terrible, and by extension, how we can understand medical tests like, for example, COVID tests. So let's take 50 people of our population here, and let's assume that 10% or 5 out of 50 are actual liars. Well, we know two things about a lie detector. First, it has a sensitivity, right? And a sensitivity is the likelihood that if it says something is positive that it is, of 84%. And because of how a lie detector works, that means that's an 84% chance of correctly, positively identifying a truth teller, because that's what a lie detector does. The lie detector also has a specificity of 80%. That's the likelihood that it correctly identifies a negative, which in this case would be a liar, because again, to be classified as a liar, you have to fail the lie detector test. So let's see how those two numbers play out. So with a sensitivity of 84%, that means 38 out of the 45 truth tellers would be correctly labeled. And with a specificity of 80%, that means 4 out of the 5 liars would be correctly labeled, as shown here. So here is our issue, because if we send everyone home who was determined to be telling the truth, and send everyone to jail who was determined to be a liar, we end up with 7 people out of the 50 who were telling the truth still in jail, only 4 out of the 5 liars in jail, and one of those liars gets to go home along with all the other truth tellers. So first, I think now you can appreciate why a lie detector would not be a good instrument to use in court. There's too high a chance of sending an innocent person to jail if that were the primary evidence. And coming back to things like these COVID tests we've been taking, you can also appreciate the balance between specificity and sensitivity. Because in general, the more sensitive that you make a test, the more likely it is to catch, let's say, disease, but also to have false positives to indicate disease when there isn't some. On the other hand, the more specific you make the test, the more likely it is that there is a false negative, that if it says yes, then you're sure that that person is sick. But if it says no, there is an increased chance that the person is still sick. So I hope this is helpful to you. This is basically some really core statistical knowledge in, I hope, an easier to digest format than what you might find in your textbook. Thanks as always for enjoying the channel. Please follow, like, and comment with what you'd like me to talk about next.